Are you just starting your journey into the world of data and databases? Don't worry. In this video, we'll explore the basics of files, data, and databases. Mastering these fundamentals will empower you to build applications that require a database and set you on the path to data analytics and data science. Let's jump in. You've likely created numerous files on your laptop, especially plain text files, to store your data. As a developer, you should be familiar with some of the most common file types and formats, as illustrated below. When your data is small, storing it directly in a file is practical, as it's easy to find, modify, or delete records as needed. However, as your data grows, managing it can become increasingly challenging. This is where a database management system comes into play. A database management system is software designed to store, organize, manage, and retrieve data effectively. There are various types of databases, but they typically fall into two main categories: relational and non-relational. Relational database. A relational database organizes data into tables made up of rows and columns. However, one significant limitation of a relational database is its fixed schema, meaning that all records must adhere to the established table structure. Some of the most popular relational database management systems include Oracle, PostgreSQL, MySQL, SQL Server, and to interact with these databases and manage data, you'll need to learn structured query language, which is why they are often referred to as SQL databases. Non-relational. In today's world, where quintillions of bytes of data are generated daily from social media posts to IoT devices, producing sensor data and streaming services, storing multimedia content, relational database often lack the ability to handle semi-structured or unstructured data. They also struggle with horizontal scalability to accommodate such massive data volumes. This is where non-relational database come in. Non-relational databases employ different data models that deviate from the traditional rows and columns structure of relational database. There are four main types of non-relational databases: document databases, key value stores, column-oriented databases, and graph databases. These databases are better suited for handling semi- or unstructured data, offering flexible schemas and supporting massive data volumes through horizontal scaling and distributed systems. Examples of non-relational databases include Mungad, Cassandra, Redis, and Neo4j. Let's learn how to use a relational database. Installing a relational database. To get started, you can download the community version of your preferred relational database from the internet and install it on your local machine. For instance, I have MySQL running as a service on my Mac. Connecting to a relational database. To connect to the database server, you'll need a client tool. MySQL database comes with its own client tool called MySQL, but you can also use other options like Deviver if you prefer. Structured query language. The language of relational databases. Once connected to the server, you can issue data definition or manipulation commands using structured query language. Let's explore some of the most common commands. List the databases. Use the show command. A database is a container that holds a collection of related tables, distinct from the database server itself. Create a database. Use the create database command. This command allows you to organize and store related tables for your application. To connect to your newly created database, use the USE command. Alternatively, you can connect directly during login by appending the database name to the login command. Create a table. Use the create table command. Let's create 3 tables based on this database relationship diagram. The student_details table stores student IDs and names. The course_details table holds course IDs and descriptions. And the student_marks table records the marks of all students across their courses. After creating the tables, you can check their structure using the describe command. Insert a record. Use the insert into command. List the records. Use the select command. If you don't specify a where clause, all records will be returned. Using asterisk will include every column in the result. Similarly, you can create additional tables and insert more records. In the student_marks table, the student and course columns reference the IDs defined in the student_details and course_details tables to ensure that the child table only uses values from the parent table. You can define a foreign key constraint on the child table. However, we won't add that constraint here for simplicity. Update records. Use the update command. This command will only update the rows that match the specified condition. If no condition is provided, all records in the table will be updated. Delete records. Use the delete from command. This command deletes only the rows that match the specified condition. If no condition is specified, all records will be deleted. Delete a table. Use the drop table command. Exercise caution when using this command, as it will permanently remove the table and all its data. With a strong grasp of these concepts, you're well equipped for the next phase of your software development journey. Join us again as we dive into advanced topics and explore related concepts. Thank you for watching, and see you next time.